SUMO, short for Simulation of Urban Mobility, is a traffic simulation software used to model how vehicles, pedestrians, public transit, and traffic systems behave in real-world or planned environments. It allows researchers, city planners, engineers, and transportation developers to study how traffic flows across road networks and how different factors influence movement. SUMO can simulate anything from a small-town intersection to an entire city road network, making it a powerful tool for planning and testing transportation systems before making real-world changes. Developed as an open-source project, SUMO is free to use, highly customizable, and actively supported by a large global community. It is widely used in universities, government agencies, and companies working in areas such as smart cities, autonomous driving, public transportation optimization, and mobility research. Traffic is a complicated system. Every day, millions of people drive cars, ride buses, bike, or walk through city streets. These movements interact in unpredictable ways. If one road becomes congested, the traffic may spill into neighboring streets. If a traffic light is timed poorly, long queues may form. If train schedules change, commuting patterns shift. Making changes in the real world can be expensive, time-consuming, and disruptive. SUMO allows planners to explore what-if scenarios without real-world consequences. What if we add a new traffic signal? What if we widen a highway or close a lane? What if we add more buses to a route? What happens if there is an accident? How would a city respond to autonomous vehicles? Testing these ideas in SUMO shows how the traffic network responds, allowing decision makers to choose the most effective solutions. SUMO uses digital maps, often the same ones used in navigation apps, to create realistic road networks. These maps include road shapes and lengths, lanes and intersections, traffic signals and their timing, speed limits, and turn restrictions and rules. Once the map is created, SUMO allows simulation of vehicles and movement patterns, including how many cars enter the network and when. It also models vehicle types like cars, trucks, buses, and bicycles, along with driver behavior such as aggressive, cautious, or distracted. Public transit schedules and pedestrian movements are also integrated. SUMO then uses these settings to simulate how vehicles move through the network over time. The results can be visualized as animated traffic, exported to data files, or integrated into larger smart city systems. SUMO is completely free, unlike many professional traffic modeling systems. Because the source code is open, users can modify or extend the software to suit specialized needs. SUMO can simulate a single intersection, a campus or event ground, or a city with millions of vehicles. This flexibility makes it useful in both research and practical field. SUMO models acceleration and braking, lane-changing decisions, and how drivers follow each other. It also models how traffic emerges, queues, and disperses, allowing simulations that closely resemble real-world behavior. SUMO can work with autonomous vehicle simulators, traffic light control systems, artificial intelligence experiments, and IoT and sensor networks. For example, researchers can test whether an AI-controlled traffic signal reduces congestion before deploying it in the city. Transportation engineers test changes to road networks such as roundabouts, new lanes, or redesigned intersections before construction begins. City planners evaluate how public transit improvements, bike lanes, or pedestrian zones affect overall mobility. Researchers study traffic phenomena, autonomous driving interactions, and emergency evacuation strategies. Automotive and tech companies test vehicle behavior, routing systems, or self-driving algorithms in a simulated environment before real-world deployment. Universities use SUMO in teaching because it is free, visually intuitive, and supports large-scale experiments. SUMO can simulate different timing strategies to reduce waiting times and emissions at intersections. Cities can test how changes in bus routes or train schedules affect congestion and travel times. Researchers can explore how lane closures, speed limits, or toll pricing influence traffic density. SUMO can integrate with real-time data from sensors, helping design intelligent traffic systems that react automatically to changing conditions. SUMO helps test how self-driving cars interact with human drivers, traffic rules, and unpredictable events. Transportation is one of the most interconnected systems in modern society. When traffic works well, cities are safer, cleaner, and more efficient. When it breaks down, the results include wasted time, economic loss, increased emissions, and road stress. SUMO allows us to understand and improve mobility before making real-world changes. It reduces risk, saves money, and helps ensure that transportation systems work for everyone. SUMO Traffic Simulator is a powerful open-source tool used to model and understand traffic behavior. By simulating vehicles, pedestrians, traffic lights, and transit systems across realistic road networks, SUMO helps planners, researchers, engineers, and companies design better transportation solutions. It provides a safe environment to test ideas, optimize city infrastructure, and explore the future of mobility, including autonomous vehicles and smart city systems. SUMO helps us experiment with traffic ideas digitally, so we can build safer, faster, and smarter transportation systems in the real world.